Welcome back to the Falling Walls Breakthrough Conversations. We have created this environment to have conversations with global leaders, outstanding scientists, emerging innovators, and science entrepreneurs. We're discussing their research, their career paths, and their general life experiences. I am your interviewer for this session. I am science journalist and communicator Adam Levy, and I'm not going to be the only one asking questions, because the special thing about these conversations is that you can take part as well. If you have a question of your own for our guest, please just raise your hand virtually using the Zoom function. You'll then be spotlighted, and when I gesture to you, you can ask your question. You'll be unmuted. After you ask your question, you'll be muted again, and so if you have a follow-up or anything like that, please just raise your hand again and we'll go through the process again. If you have any technical questions, just drop them in the chat, and otherwise enjoy the conversation. And just so you know, the conversation will also be viewable after the event on the Falling Walls website. Now, I am joined by Günther Hasinger, Director of Science at the European Space Agency. So thank you so much for joining us.
Yes, thank you very much. It's a great pleasure to be with you, and I really look forward to this whole event.
So, I mean, your work has covered a great deal, but we're going to be focusing today on the exploration of our solar system, and particularly, I suppose, the motivation for a lot of that exploration. Why do we want to explore our solar system and specifically travel to different parts of our solar system?
I think this is a deep belief or necessity, that humans have. They want to know where they are, where they came from, where they go to. And it started with our own globe, right? People wanted to go into the most distant parts, to the North Pole, South Pole, to the highest mountains. And now we have the ability to go out into space, to the nearby objects, the solar system. And I would also say we have the possibility to explore the universe. I mean, only with our eyes and ears, but we want to know what is out there.
Often when this question comes up, a single word comes up often very quickly, which is life. And of course, we know that this planet is abundant in life. We're still learning new things about it. But life anywhere else is still this big unknown question.
Yes, but I think we are learning more and more, and we are finding life in areas that we would never have expected. And we find the building blocks for life, the kind of the Lego blocks out there in space. So for instance, a lot of organic molecules are in interstellar clouds. I always say jokingly, there's more alcohol out there than here on Earth. And when there are asteroids falling down to Earth, you can also see that there are organic materials there. One asteroid has found 21 amino acids, for instance. And then when we look on Earth, we have found life in regions that we would have never expected. For instance, deep down in the ice of the glaciers, deep inside the Earth, there are bacteria that have never seen the sun. And people believe that there is actually more biomass below the Earth's surface than above the Earth's surface. And then we have found these fascinating so-called thermal sources, thermal wells at the ocean floor, which are believed, the so-called black smokers, which are believed to have created life. So there is the idea that the building blocks of life are kind of raining down on everything, and you just have to have the right conditions to search for. And therefore, the planets in the solar systems like Mars, maybe even Venus, might have had water before. And if water is there and sun, there is very likely life. And there are also these so-called fascinating ocean worlds, smaller planets outside Jupiter and Saturn, which might well contain lobster.
The hunt for the lobster continues, but I find it fascinating, this idea that understanding life on this planet and discoveries of life on this planet actually help us in the search for life beyond. But let's actually think about what that search looks like, because when we're talking about exploring other planets and visiting other planets, we're not talking about humans actually going to these planets yet. What does this exploration involve?
Indeed. So there's one part of exploration that goes to where humans might go later, like, for instance, the moon, Mars. But then there is also exploration in the outer solar system where we very likely will never go on foot, but with robots. Now, if you look for life, you have to know that the space is a very dangerous place, so that means all living material is very likely eradicated by radiation, by the weathering of the solar system. And so, for instance, when we are looking at life in the upper crust of Mars, very likely we don't see any active life. There might be dead life, so to speak. And this is what the Perseverance rover is now aiming for, and the so-called Mars Sample Return mission. So they want to bring several pieces of rock down to Earth and to analyze it in greater detail. However, if you really want to have a chance to see maybe existing life, I mean, if it were still there in the Mars surface, you have to dig deeply. And this is what the European ExoMars rover is planning to do next year. With a drill that has 2-meter depth and can actually go into regions that may have a chance of surviving this deadly environment.
You've captured a bit there the current state of the art of robotic explorations, and we should mention these rovers on Mars that we have now. They're not tiny little buggies; they're kind of Jeep-sized vehicles.
Yes, or a VW bus or something like that.
Yeah, I strongly recommend you watch kind of the digital simulation of how they land on Mars, which is just an incredible feat.
And even through video material, I mean, in my talk I show the actual descent video, and this is really breathtaking. Yes.
That's absolutely the word, just breathtaking. But that's where we are today. What's the future of robotic missions? And you mentioned the possibility of returning samples to Earth.
Yes. So let me first do a little detour. Another possibility is to look for life in other planets, in exoplanets. You know, we have discovered about 4,000 planets in other solar systems. And there is a chance, and with technology getting better and better, we might have a grip to see, for instance, conditions on the atmospheres of these planets. We will launch the James Webb Space Telescope in December this year, and that will actually be able to study the surfaces, the atmospheres of planets. And the holy grail is to discover a kind of Earth B, a second Earth-like planet, which we do not have so far. But now, what is the future? The kind of science fiction dream that we have developed is there are these icy moons, those ocean worlds. There's one very promising, Europa, next to Jupiter, but Europa is in the middle of Jupiter's radiation belts, and it's very hard to get to. There is another moon called Enceladus in the Saturn system, and that's actually a nice and cozy place, and that is a place where we are currently dreaming of to go there, land, and then dig into the ice and bring an ice core back. Why do we do that? I mean, these ice layers on top of those oceans are a few, I mean, maybe 1,000 kilometers thick or so, or at least much thicker than you can drill through. But there are actually cracks in this ice, which are created by these thermal vents on the ocean floor. And there is water coming out like geysers in Iceland. And so what we want to do is maybe fly through this ice, through this water, maybe land on the surface to study the material in depth. But I think the real holy grail again is if we could bring some of that material back to Earth. And I would just like to tell people that, you know, the Apollo samples, you know, Apollo brought a lot of stuff back to Earth, but there is one sample that has never been opened. It is including the atmosphere of the moon. And so it has been sealed. And since 50 years, it has not been opened. And now, actually, European Space Agency has developed a machine that can actually open this sample without destroying it and study it for the first time. So the bringing stuff from other solar system bodies back is a value in its own.
You speak about this as a dream, but it's not just something that you're thinking about in your sleep. This is something that there is real hope and real ambition to do. But What are the time frames for something as ambitious as this?
Yeah, I mean, the dream is in a sense because such a mission is so expensive that we Europeans currently cannot really afford it yet. I mean, we hope that we can convince member states and maybe also international agencies to partner with us, that we can raise enough money to make such an ambitious mission. If we could build it, it would take about 10 years, so we could probably think about launching it the earliest end of the 40s. Then the travel time to Saturn is about 10 years. Then you land there, and by the way you come back, it's already 2060. So I don't think that we will be alive, but our future generations will have a real precious piece in the hand. So it's science fiction in the sense that the timescales are so long and the required money is significant, but it is possible. It's technologically not science fiction.
I'm going to restrain myself for a second to asking my next questions and turn to the audience because we have a question from the Falling Walls audience. I think you're now live, so go ahead.
Saskia.
Yes. Hello, my name is Saskia, and I'm not an expert in that field because I'm a sociologist, but I would be very curious about what would be the ideal or most interesting outcome of the expedition when you drill like 2 meters in the ground on Mars. So what can you expect, or what would be very nice for you or for your researchers? Yes. What would be an ideal outcome of that mission?
A very good question. Yes, thank you very much. Actually, when we drill in the surface, we might get fossils, for instance. So we could see fossilized bacteria. But what would be really the dream is to get live DNA. I mean, if there is a live bacteria and we could get this and analyze it, it would be extremely interesting because we know that on Earth, all the DNA has actually one-handedness. It is all basically the handedness of the spiral is in one direction. And it is not quite clear why that is. And so suppose we detect life elsewhere and it has a different handedness, that would immediately be a huge opening. If it would the same handedness, then it would still tell us something. And so we believe by finding the origins of life and finding life elsewhere, we learn also a lot of life on our own planet.
There's a real sense in which, of course, there's such an abundance of life on this planet, but it's also in some sense a data point of one. All the life on this planet is evolved from a common point. And so to suddenly have a second data point could teach us so much.
Indeed, yeah. You know that since we are exploring the skies and the heavens, humans have been moved further and further away from the center of the universe, right? Originally, the idea was that the Earth is in the center of the universe. Then we realized the Copernican revolution, we have moved out and we are just one planet in the sun. But then at least the sun was thought to be in the center of the universe. Now the sun is at the outskirts of a galaxy. And more we learn that we ourselves, in our human beliefs, are only a small kind of fraction of what is out there. If we now find that our type of life is also only one among many, that could also change our perception completely.
Well, that brings us back to a point you mentioned earlier, which I'd love to return to, which is the question of life on exoplanets, life on planets which don't go around our star, but go around other stars, either in our galaxy or even galaxies beyond. Now, this is a topic I find fascinating because when I was born, we didn't even know if such planets existed. And now we know of thousands of them. But I mean, when we're struggling to find life on our planet, sorry, not on our planet, in our solar system, can you elaborate how we could possibly hope to find hints of life on other planets?
So this again brings us back to Earth. We have now, in the meantime, understood better our own evolution of our Earth. And you know, Earth in the beginning did not host life, right? It was a barren planet. It was dominated by CO2, similar to what Venus is right now. Then there were the first bacteria, the so-called blue algae, and they were eating CO2 and were creating oxygen. So their waste was oxygen and their food was CO2. They completely destroyed their environment because they ate up all the CO2 and turned it into oxygen, and oxygen was deadly for them. But that was basically what that enabled us to live. So they did terraforming for us and preparing the Earth for normal air-breathing species. Now, if you look at the spectra of Earth before the bacteria were there and then afterwards, there are huge differences because one spectrum is dominated by CO2 and the other one sees all of a sudden oxygen appearing. People even believe that nitrogen, you know, our atmosphere consists of oxygen and nitrogen, that nitrogen was made by bacteria as well. And so when you look at the surface, at the atmosphere of other planets, you can look for so-called biomarkers, molecules that are very likely produced by living species, and that's the only way to do it right now.
I'm going to turn back to our audience who have, I'm not surprised, another question.
Thank you very much for the opportunity to participate. I'm actually an astrophysicist. I study atmospheres of other exoplanets in Switzerland. So I'm very happy with the discussion going on. I guess I saw your background, or like the talk was more focused onto planetary science, solar system objects. So as an exoplaneteer, I would like to ask you, what do you think is that next topic I, as an exoplaneteer, could learn from planetary science from solar system as to focus my research on, like in the future? What do you think is going to be like? Yeah, with JWST, we might find this, and we should start looking at this niche topic because it's going to be relevant.
So this is not so much focused on life itself, but on the generation, the how the solar system formed in the first place. I mean, as usual, we are always comparing everything to ourselves. When we look for life, we look for little green men, but they should be men or women, but not something else. When we look for exoplanet systems, then we were expecting things similar to our solar system. And we were completely surprised because the very first planets we discovered were nothing like the solar system. There was something like Jupiter, very close to its sun, so-called hot Jupiters. And there are now, it's clear that most of the planets in the galaxy are actually not existing in our solar system. Most of them are heavier than Earth, but lighter than Neptune. We call them super-Earths and mini-Neptunes. And so just the sheer understanding of how planetary systems form is not yet there, and we need to understand our own solar system. There's one guy which is a kind of oddball out, which is Mercury. Because when we look at Mercury, its closeness to the sun, its size, its weight doesn't quite fit into the other planets have a regular series. When you go further out, they get lighter and bigger. And Mercury is the oddball out. It also has a magnetic field. We don't know where it comes from. And so we are currently sending a probe, Bepi Colombo, to Mercury. And it will arrive there in 25, at December, at Christmas 2025. And it will study Mercury in great detail. We also have just decided that we want to send a probe to Venus, because Venus is also very little understood. Venus is a sister of the Earth. It may have had water or not, we don't know. It may have continental drifts or at least tectonic motions. Venus is completely ill understood, and a lot of attention goes to Mars now, and we want to send several spacecrafts to Venus in the next 10 years. So understanding our own planets to a greater detail will then also enable us to understand extrasolar planets, and vice versa. Having the statistics of the extrasolar planets will help us guide our understanding of our solar system.
We've been talking, I suppose, almost exclusively about planets and terrestrial bodies, but I'm very curious about another space body that you've worked on, which are black holes, which seem, I mean, fine, they both exist in space, but it seems thematically incredibly different to planetary science. What's it like for you having, your feet in such different domains?
Actually, there is now a link appearing, which is fascinating, which I don't want to hide. I believe, this is still a belief, but it's supposed to be confirmed. You know, we don't know what dark matter is. And on the other hand, also, we find black holes everywhere where we don't expect them. And now the theory, which I have also published papers on that, is that maybe black holes are actually the dark matter. Those black holes must have been created in the very first seconds of the Big Bang. But this is physically still possible. There are theories that can explain that, and that then all this dark matter in principle around us would be black holes, but they would not be of a single type. They would have a very broad distribution. So there could be light black holes, which are not heavier than a sun or an Earth. There could be very heavy black holes, the supermassive black holes that we are finding in the centers of galaxies. And in this picture, it would indeed be true that galaxies are formed around the black holes. The black holes were there first, and then the stuff is coming and creating stars. But the fascinating part about that, coming back to the solar system, is that it might be possible to have planetary mass black holes. So black holes which are of the mass of the Earth, or 3 or 4 times the Earth. If you would squeeze the Earth into a black hole, it would not be bigger than your thumbnail. And you know that there is a so-called Planet 9 mystery out there. There are people who claim that there is another 9th planet. I mean, we have killed Pluto, which was the 9th planet, so now planet number 9 is an unseen object, which, however, seems to shake the other Pluto-like small dwarf planets around. And that Planet 9 has been looked for very, very hard. People were trying to find it and didn't find it. So now there is a speculation that Planet 9 may actually be a black hole. And if that's true, that would be really mind-boggling.
When I kind of mentioned that these are very different questions with very different scales, I wasn't expecting the black holes to be the thumb-sized scale. I'm going to turn back to our audience, and we've got another question coming in.
Hello. Thank you very much for the opportunity to speak. I was wondering if there's any research currently going on about Omar, or the conversation is already closed. Maybe European Space Agency is doing something about that. Maybe discusses regarding its artificial origin or something like that. Would be really interested to hear that. Thank you.
Thank you very much. This is an excellent.
This in some context for
yes. This is an excellent question. This is about Oumuamua. Oumuamua is a Hawaiian name for a scout that comes from the far. He's actually preceding his army. He's coming for the first time, and indeed. This object I love because when I was in Hawaii, it was discovered. I was director at the telescopes that discovered this object. It's the first interstellar visitor where we know that it came from another stellar system and visited us. In the meantime, there's another one, Borisov, which is the second interstellar visitor. And this has actually opened a whole new idea about how life could travel within the galaxy, because if it is possible that a piece of our own solar system is actually traveling somewhere else, then in principle life could be brought somewhere else. I mean, you could imagine an asteroid impinging on Mars or on Earth and then spitting out material, and then some of that material could go so fast that it is actually traveling to another solar system. Now, the fascinating thing about Oumuamua was that it visited our solar system and then it accelerated away with a faster speed than it came in. And it also had this very strong, very funny shape like this microphone. It was much longer than small. And therefore people started to think maybe it could be an alien spacecraft that has visited us and so on. But in the meantime, I think we have much simpler explanations. From my point, the best explanation is that, Pluto, the surface of Pluto is consisting of nitrogen ice. Is it nitrogen ice? I believe, yes. CO2 ice. Anyhow, it's an ice material. If you hit something, if you hit Pluto with something and you are ejecting a piece of the surface, then this is basically what Oumuamua could be. It could be an exopluto fragment that came to our solar system and visited us. As soon as it sees the sun, it's getting hot and the ice is actually melting, but it's not really melting, it's turning into gas, and that gas is accelerating the object out. And if this is true, then it's also understood why it is so much flatter than long. This is a little bit when you are in your shower and you take your soap bar, And when you use it a long time, then it gets smaller, but it's also getting flatter and flatter. And that's the way Oumuamua actually might have achieved this funny shape. So there's a natural explanation for it, but it could carry much more message. And you were asking about, sorry for taking so long, but you were asking about what ESA is doing about this. As soon as we have realized that this is such an important aspect, we have actually created a new type of mission, which is called an F mission, a fast, flexy, furious, fantastic mission. And this mission has been selected to be Comet Interceptor. It is a mission which will fly out into space, and then it waits until a new comet is discovered that has never visited the solar system before. And so such a system could also be an interstellar visitor. So we might be able to visit the next interstellar visitor with a spacecraft.
I'll have to jump in there, but
Yes.
I think it's a lovely place to stop because we've spoken about our solar system, other solar systems, and what better place to stop than a visitor from another solar system to our solar system. We could carry on for a long time, but our next interview has to begin in just 5 minutes. So stick around and you will be joined by Claire Gray. Thank you.
Thank you very much. A great pleasure for me.